So we're going to talk a lot more about Venn diagrams. And so I want to give you this scenario, and this is not on your handout, it's just something for you to ponder, okay? So just think about. Suppose we were to survey the class to see who was blonde and who has blue eyes. Well, there are 4 possible things that can happen. The first thing is that no students that have blonde hair also have blue eyes and vice versa. So in other words, if I ask everybody with blonde hair to stand up and they go to the left side of the room, that would be that way for you guys, okay. Then I ask everybody with blue eyes to go to the right side of the room, there wouldn't be anybody stuck in the middle. It would be 2 completely different groups of people. Okay, none of them have both of them. The other possibility is that all students that have blue eyes also have blonde hair. So this would be, okay, let's say I ask everybody with blue eyes to stand up, and just coincidentally, they all have blonde hair. Every single person that stands up. Now notice, is it possible that there could still be people with blonde hair still sitting? Yes. Okay, there could, I only asked people with blue eyes to stand up, and they were all blonde. Then maybe there's somebody with green eyes that's still sitting down that's also blonde. Okay, so it's just the blue eyes all have blonde hair. The same students that have blonde hair are the students that have blue eyes. So this time, when I ask everybody with blue eyes to stand up, they are all blonde, but also there are no other blondes sitting down in the room. So they are the same group of people. Everybody with blue eyes has blonde hair, and everybody with blonde hair has blue eyes. So that's the third possibility that could happen. And then the fourth possibility is that some students that have blonde hair also have blue eyes. Now imagine the first scenario I gave you, that I asked everybody with blonde hair to go to the left side of the room and everybody with blue eyes to go to the right side of the room. Well, the last possibility here is where there would be some people stuck in the middle, and they're not sure which group to belong to because they have both. So some of the students that have blonde hair also have blue eyes. All right, we can represent these scenarios with Venn diagrams. So disjoint sets have no elements in common. So your fill in the blank there is disjoint. And what I'd like you to do is just at the top of your handout, write set A is the students with blonde hair, and set B is the students with blue eyes. So not in the space, just at the very top, write those 2 sets. Because we're going to repeat these sets for every single example on your handout. So just write them once at the top. So in the space under the disjoint set statement, you can write that this represents the statement that no students that have blonde hair also have blue eyes and vice versa. So this picture represents no students that have blonde hair also have blue eyes and vice versa. Okay, no students that have blonde hair also have blue eyes and vice versa. So notice when you have that keyword, I underline the keyword no for a reason there, because no means that you have disjoint sets. You have 2 circles inside your Venn diagram that do not touch whatsoever. They have nothing in common. Okay, the next picture shows proper subsets. Set B is a proper subset of A. So notice that the circle for B fits inside of the circle for A. Remember that proper means that it has less elements than A, and everything inside of that first one also belongs to the second one. Okay, so you already wrote down sets A and B at the top of the page, so you don't have to write that down again. But this picture represents the result that all students that have blue eyes also have blonde hair. All students that have blue eyes also have blonde hair. So this time I underline the word all because that's the key word. You're going to be given sentences like this, and you want to be able to identify what your picture should look like to match that sentence. So if you see a keyword of all, that means that whatever the first group they're talking about, all of that has to fit inside of the second group that they talk about. If A equals B, then set A contains exactly the same elements as set B. I think it's on the blank as exactly, is that right? So you have the same two sets, and this time this picture represents the same students that have blonde hair are the students that have blue eyes. So notice I only had to draw one circle in my Venn diagram because we're showing the same representation, but I labeled it with A equals B in the Venn. Okay, so then this picture shows that set A and B have some common elements. Notice that the two circles overlap a little bit, and so that yellow portion is the elements that they have in common. So same two sets, and this picture represents the statement that some of the students that have blonde hair also have blue eyes. They have some elements in common, but also have other elements that they don't have in common. Now, if you end up having to draw a Venn diagram that looks like this, remember that I mentioned that you want to start with the innermost portion and work your way out. And let's talk about what all these regions represent. So if you start with the innermost portion, that yellow region represents the students that have blonde hair and blue eyes. So if you had to list the name of the students in your Venn diagram, let's say, you would start with those that have both, and you would write their names in that area. Then you could move over to the blue portion, let's say, and those would be the students that with blonde hair, but they don't have blue eyes. So you would write those names in there. Then the gray region would represent students with blue eyes but don't have blonde hair, and you could list their names in there. And I don't think I labeled it on here, but what does the white space represent? Good. Students that do not have blonde hair or blue eyes. Good. So anybody else that's left basically in the classroom that wasn't already written in there, you would have to write them in that white space right there. So any questions about what those regions represent? Some of your homework questions, and we'll probably pop in an example here or there, just ask you what, if you're looking for this representation, which regions are you looking for? And they're going to ask you to find that. Okay, so now that we're really familiar now with what a set is, what it might represent, then you can do some operations with them. So the intersection of sets A and B, and you write this with it almost looks like an upside down U. These are the sets of elements that are common to both set A and set B. And then you could also write it in set builder notation as follows here. And I think you're missing the set builder notation. Is that right? What are you missing on there? Oh, the word intersection. Okay, so the word intersection is your fill in the blank. Now I want everybody to circle the word and that's inside that set builder notation. Because and is a key word here. And is the same thing as the word intersection. So if you're asked, find the intersection of sets A and B, you could also be asked to find all the elements in A and B. So if you just see the word and, it means the same thing as intersection. And this means that you are looking for what they have in common. So intersection always means what they have in common. So here you have, this could be what your problem looks like. You have a set, that intersection symbol, and another set. So if you're looking for the intersection, what are you looking for? Right, the same numbers are what they have in common. So what do these two sets have in common? A 10. And so you would write the set of the element 10. So, yes, question? Okay, so the numbers that are in common here are the only element in common is 10. Now remember that your answer should still be in set notation because the intersection is still a set. All right, so here's the next one. You're finding the intersection of these two sets. There is nothing in common, right? So what set would represent no elements? The empty set. Okay, so since there is nothing in common, you would choose the empty set. And you could write it either one of these two ways. You could choose to do braces with nothing in it or the circle with the slash through it. In Math Excel, you just have to see what choice they have as that. Okay, so the union of sets A and B, written with this time the symbol for union looks like a U, which is sort of nice because the word union starts with the letter U. So if that helps you to remember what these symbols mean. So union is the one that actually looks like a U, and these are the set of elements that are members of set A, or of set B, or of both sets. This definition can be expressed as follows here. A union B equals the set of all elements X such that X is an element of A or X is an element of B. So what's the key word for this one? Or. So the union is going to be set A or set B or both. In other words, you're joining the two sets together. And if you want to write that down, and if you think about a union, you know, for example, you know, sometimes marriage is called a union because you're joining two people together in marriage. So you're joining whatever, so anything you see in both sets belongs to the union. All right, so here is your example. You want to find the union of these two sets, 6, 7, 8, 9, 10, 11, 12. Good. So you want every element that you see. If you're going to find the union, you want all the elements that you see in either set. Okay, so here's your next problem. Very good. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And by the way, order doesn't matter. So if you happen to write down 1, 3, 5, 7, 9, comma, 2, 4, 6, 8, all into one set, that would still be the same set. Just make sure you're paying attention to any other, you know, unless it specifically says write it in ascending order, then this is the only way to answer it in ascending order.
Would we be able to do the dot, dot, dot?
In Math Excel, you can't do the dot, dot, dot because it wants you to specifically type all of your answers in there. And, you know, if you were doing something for me in paper and you showed me that, then that would be okay. But your tests are going to be in the computer, so you want to get really familiar with what Math Excel is saying. Okay, so for any set A, there's two things that can happen when you're dealing with the empty set. So number one, your fill in the blank is the answer to that equation there. So A intersected with the empty set is always going to be the empty set. Because think about it. Will A ever have anything in common with the empty set? No. So this example here, I keep wishing if I'd rewrite this. It makes a little bit more sense when you look at the other way to symbolize it. So when you compare these two sets, set 1, 2, and 3, and the empty set, there are no elements in common when you have the empty set. So therefore, your answer to that intersection is just the empty set. Okay, number 2, A union with the empty set is always going to be equal to A. So if you're taking the union of a set with the empty set, does the empty set have anything else to contribute? No. So therefore, the union is just going to be everything in that other set. So this is two things that you know when you're dealing with empty sets in intersection and union. If it's in the intersection, the answer is always going to be empty set. If it's the union, then the answer is always going to be whatever the other set is. So if set A contains 30 elements, set B contains 18 elements, and 5 elements are common to sets A and B. How many elements would be in the union? So this time they want to know the number of elements, not the actual elements. So how many elements would be in the union of A union B? It's not that straightforward, is it, when you're looking at this? Okay, so yeah, you get a couple different questions. Now, there's 2 ways you can do this. I will show you a formula for it, but I want to first show you one way that we can visualize how many elements are in each set. If I create a Venn diagram, I have set A and B, so I need 2 circles, and I know that they have elements in common, so I'm going to go ahead and draw it so that they have a section in common there. So this time when we draw this Venn diagram, instead of the actual elements in the Venn diagram, we're going to write how many elements are in each region. So we still have to start with the innermost portion and work our way out. So how many elements are in the yellow region? 5, because they have 5 elements in common. So now if we move to the blue region, how many elements belong to the blue region? 25 is correct. Good. Why? Right, you've already represented 5, and you know that there are a total of 30 elements in A, so it's always a series of subtractions here. So you got to take away those that you've already represented, and what's left is what goes inside of the blue region. Good. So how many elements belong to the gray region? Okay, 13, because again, you know that there's a total of 18 in this entire circle. You have already represented 5 of them. So when you subtract, that's how many you have left. So 13 in that gray region. And then what belongs in the white region? Just the white. Any numbers go in there? At this point, you don't know, because they didn't tell you anything else about the universal set. So you just leave it blank. Okay, so if you look at what's in the union includes anything that's in A, anything that's in B, or anything that's in both. So basically you're looking at everything inside of those 3 regions. So if you add that up, 25 plus 5 is 30, plus 13 is 43. And some of you guys said 43, some of you said 48. Notice, what's the difference between 43 and 48? 5. And if you just add the 30 with the 18, then that means you're counting those 5 elements twice. Okay? And so therefore, you've got 25 plus 5 plus 13. So another way that you can look at it is using a formula. And you guys, we used this notation last time, the little n outside parentheses. Remember, the little n means cardinal number or amount of elements. So this is the amount of elements in A union B, which equals 43. So just a reminder on that symbol there. Okay, so you don't necessarily have to use a Venn diagram to do this, but if you know that you take your 30 elements in A and you add them to your 18 elements in B, but consider that you're counting those 5 elements that are in common twice, just subtract those items that they have in common from your total, and that'll get you back down to 43. Okay, so notice that the way that they listed it in the formula, you need the number of elements in A plus the number of elements in B minus the number of elements in their intersection, which is really the same as saying the number of elements they have in common, because that's what intersection means. Or you could also use the word both, if that helps. The number of elements in both. Okay, this is a larger set of questions, but a lot of your questions go pretty fast in here, because it's just observing and putting an answer down. Okay, it says, let U, or the universal set, equal the set of 1, 2, 3, comma, dot, dot, dot. Let set A equal the set of elements 1, 2, 3, comma, dot, 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 47. And it just wants you to find A complement. That's what A apostrophe means, A complement. It says use a comma to separate answers as needed and use ascending order. So ascending order means start out with the smallest number and then move up from there. So remember that A complement means that you want anything that's in U that is not in A. So if we eliminate all of the numbers that are in A, what number should we start with? 48. Good. Okay, 48 comma, then what would the next number be? 49, 50. What's going to happen to this list here? Okay, it goes on forever, right? And so let's see if it accepts our dot, dot, dot. You do need to have a comma after the last number, just so you know that. That's the proper way to put that. Okay, well done. So write at least 3 numbers in there to show your pattern, and then your dot, dot, dot. Okay, so here's another way to ask the same question, but this time the sets are not infinite. So again, if you want A complements, then all you have to do is eliminate the items that are in A from U. So if you want to actually cross them out, I'm going to cross out a 5, a 6, an 8, and a 10. So the complement are any elements that are left. Okay, 7, 9, and 11. So you type 7, comma, 9, comma, 11. And this would be the scenario where you have to list all of your numbers. Even if there's a pattern, it's not going to want you to do the dot, dot, dot in the middle. And you don't have to put a space after the comma, but I don't think it marks you wrong either way. You could put no spaces, or you could put spaces after the comma. Okay, so here's a notation that can be a little bit more complicated. You have the universal set is 1, 2, 3, 4, 5, 6, 7. Set A is 1, 3, 5, 7. And set B is 3, 4, 5. So they want you to find this. And what that means is you're looking for the complement of the union of the two sets. Now, set notation, set theory, is the same as any other type of math where you have to follow order of operations. So if you're following order of operations, that means you want to do what's inside parentheses first, and then work your way outside of parentheses. So inside, that means it wants you to find A union B. So we're going to start out with that, A union B. And so if you're just finding the union between A and B, what elements should be in there? Okay, so would the union be only what they have in common, or everything? Yeah, everything. So the union means everything that's in set A or B. So the union would be 1, 3, 4, 5, 7. I'm doing this problem in steps. I'm just finding the union right now. Okay? So I'm doing what's inside parentheses, and now my next step for order of operations would be to now move outside of that parentheses. And so now I want to find the complement of A union B. So I'm looking at A union B, and I want to eliminate any of those answers from the universal set. So now compare back to the universal set. And the complement means that I am going to cross out 1, 3, 4, 5, and 7. So eliminate those from the universal set, and what's left? Okay, 2 and 6. So my final answer is the set of 2, 6. So go back to your box there and type 2, 6. Nice work. Let's take a look at some that have Venn diagrams in there. Well, this one you should be able to answer right away. What's A intersection with the empty set? Empty set every time. Okay, if you're intersecting, that means it has nothing in common. So empty set, good. You don't even have to look at what U and A are. It's irrelevant. All right, here you have a Venn diagram, and it wants you to represent the set B complement in roster form. So remember, the complement of B is anything in the universal set that's not in B. So if you want, you can just, if you draw this on your paper, and this is what I recommend, that if you guys draw it in pen on your paper, and then you can use pencil to shade out areas, so maybe if you make a mistake, you can erase that and your original Venn diagram is still there. But I could shade out everything in B. I don't want B, I want the complement. So I've eliminated B, which means the only things that are left are 3, 4, 22, and 25. Does that make sense? Now, the other way you can do it is you could list what's in A, you could list what's in B, and you could list the universal set and write all of that out, and then do it by hand by crossing out elements. But if you can do it visually, it will be much faster. Instead of actually asking you what elements are in there, it might just ask you how many elements are in there. So notice we have the little n outside of parentheses. So they want to know the cardinality of A complement. So again, that means we don't want A, so I'm going to scratch that out. And so how many elements are left once I take away A? 4. So that's what your answer would be, just 4. Nice work. Okay, and then you might have some problems in here where it gives you a definition of something and you have to base your answers on that definition. So sometimes I have time to show you these questions, but sometimes I don't. You're just expected to read through the problem. But it says a palindromic number is a natural number whose value does not change if its digits are reversed. So for example, the number 11 is palindromic, right? You reverse the digits and it's still the number 11. The number 454, if you reverse the digits, it's still the number 454. The number 261,162, if you read it from right to left instead of left to right, it's still 261,162. Okay, so that's a palindromic number. Use the definition to place 77 in the correct region of the Venn diagram, where U is the set of natural numbers, A is the set of palindromic numbers, and B is the set of even numbers. Okay, and so you are just choosing which Roman numeral it is. Does it belong to Roman numeral 1, Roman numeral 2, Roman numeral 3, or Roman numeral 4? And you can actually show me choice of fingers here. So 1, 2, 3, or 4. And I definitely have a majority of 1. So you would type, and you usually can type capital or lowercase, but typically Roman numerals are capital. And so you type a capital 1 in there, well done, because it is a palindromic number, so it belongs in set A, but it's not even, so it needs to be outside of B. So these that are in region 2, region 1 are just palindromic and not even. Region 3 are what? Region 3 is just even, not palindromic. Okay? And then region 4 are what? All other natural numbers, yeah. So the universal set is natural numbers, so they would be the natural numbers that are not even and not palindromic. So in other words, odd numbers that don't fit that little pattern. All right, so again, they might just ask you what region to choose and so on. So keep in mind we've finished up through 2.3. Your first test is everything we've covered so far, and then 2.4 and 2.5, which I plan to cover all of that tomorrow. So you should start looking at the test review so that you can have an idea of what's going to be on that test this week. And, you know, again, tomorrow we'll cover the rest of the material, but also there's some tips on the test review as to how you can study. So I'd like you to read the test review to see if you understand my tips, so that tomorrow you can ask me questions. No, I don't know what you mean by this thing that I could use to practice and so on, because I want to see if you guys can sort of find that on your own. But if not, then I can clarify those things. Question? Yes, so you've got everything, and just so you guys know, all the quizzes are available, so you guys are always welcome to work ahead. But yes, you should absolutely have seen once you do the homework, you should have seen anything that could appear in the quiz.